Hello, friends, and welcome back to Commute Talk. I heard from a lot of people that you liked WebKit stories, so I thought I would tell some more WebKit stories. So this one is after the WebKit and Blink split, so Google went off to do their own engine. And at the time, I was sharing an office with Ryosuke Niwa at Apple, and we were both on what was at the time called a WebKit performance team. And we were tasked with just, WebKit performance. Making benchmarks, improving benchmarks, tracking benchmarks, regressions, fixing those regressions, that type of performance stuff. We're trying to make WebKit go fast. And so we felt very strongly, both of us, that now that Blink had forked off of WebKit, it was like a completely fair game in performance optimization, us versus them, right? So we imagined ourselves in a sort of performance war situation, even though it was never explicit and never really acknowledged publicly by anyone. I don't know how the Googlers felt about this at the time, but to me and Ryosuke, it was on, So we had this huge whiteboard wall outside of our office where we would write in marker all the different benchmark numbers in the different browsers. So since we were working on OS X, then we were tracking Safari, Chrome, and Firefox at the time. We had some ambition to track IE, but because it only ran on Windows anyway, then it was a whole, apples, oranges, whatever thing. But we wrote down all the benchmark numbers for all the benchmarks, web benchmarks that we could think of, on this huge wall outside the office. And whenever we would always update them, I think Ryosuke would update them every week, and we would also update them right away if we made some performance improvement. And it was so motivating to have this huge wall, because you had to walk past the wall whenever you're going to the bathroom or getting a snack or lunch or going home, and you would see it when you were coming in to the office in the morning. And not just us, but everyone else would see it. So it felt very motivating to always have something, something to change, some number to go down a little bit, or to go up, in the case it was a number that was supposed to go up. I think, I recall we had these arrows that meant, higher is better, lower is better, whatever. Anyway, so one of the benchmarks that we were tracking was Dromeo, which was this really ancient DOM performance benchmark that was it was like a hardcore micro benchmark. I think made by John Resig, the jQuery guy, but I don't quite remember. But I think it was hosted on the Mozilla website anyway. And it was one of the benchmarks that we were tracking, and it was not a representative benchmark. If you got 1,000% faster on Dromeo, or some Dromeo subtest, it didn't really reflect any noticeable real-world improvement on anything. Probably there was a time when it would have, but browser engines were mostly caught up with Dromeo and had moved on from Dromeo at that point. But because we put the number on the wall, I felt we're putting this number here, so we might as well improve it, right? And I went into it with this weird attitude that Dromeo has been out for many years. It's already been squeezed to heck. People have squeezed all the performance that they can out of it, and there's going to be maybe some medium to high hanging fruit. But it turned out that there was a lot of funny low-hanging fruit that you could do for Dremio. One thing, I remember one patch specifically that I really like. So one thing that Dremio does is that it concatenates strings in JavaScript and then uses those concatenated strings to perform attribute lookup on an element, on a DOM element. And I think it even had a comment in the Dremio test sources that this is like to prevent caching or something like that. And it did indeed prevent caching, because in WebKit or in JavaScript core, the way that concatenation works, or worked at the time, was that we wouldn't concatenate the strings right away, but we would create a so-called rope string, which was like it was like a little helper object that would just point to all the different concatenated strings. I mean, the parts of that would make up the concatenated string, and it would like emulate a string object that was really just pointing to these multiple strings. And then when you tried to use that as an actual string, at that point it would concatenate the strings. And so that's what we were doing here, is that we were first we were creating one of these rope strings, and then we would hang around a little bit, and then it was time to do an attribute lookup with that rope string. Then we would concatenate the strings at that point and turn them into a real string. And I had a pretty nice way to improve this, which was that in JavaScript core, all of the property names are what's called identifiers, and identifiers are they are like runtime unique objects in C++. And I mean, that's just another way of saying that they are globally unique strings. So going from a rope string to an identifier meant that you had to concatenate the string, and then you had to deduplicate that concatenated string by looking it up in the global identifier table. And then if there was already an identifier for this character sequence, then you would get rid of the one you just concatenated and replace it with the globally available identifier. Are you still with me? So the hack that I made for Dremio to go fast was we would still create these rope strings, but when it came time to concatenate or to realize one of these ropes into a single string, then instead of concatenating it, I made this thingy that would go directly to the global identifier table and look for basically like use the rope string as an index into the identifier table, so that you could do a lookup and deduplication without having to create the temporary string. And that was a huge improvement, because all of those temporary strings that we were creating before, they meant that we were putting garbage on the heap. And so the faster we would go, the more garbage we would put on the heap, and it had to be taken care of. So not producing all that string garbage was a big improvement on Dremio that I really liked. And then there was some other stuff like what am I thinking of? That Dremio made heavy use of node lists. I mean, if you don't know what these things are, then I guess you haven't been programming JavaScript DOM stuff a lot, and that's okay. But I'm just going to go on about this as if everyone knows what these things are. So Dremio made heavy use of node lists, which are these collection. It's like a vector of nodes, basically, or an array of nodes in JavaScript. And the way that you would iterate over a node list is just by index. So you would do like for I is 0, while I is less than node list.length plus I. And that nodelist.length was very, very slow in WebKit at the time because we didn't know how to cache that property lookup. So whenever we hit that in JavaScript, then we had to go and make this we had to invoke this big mechanism that would take the string length and figure out how to get that information from this object. But JavaScript core has this fancy inline caching mechanism. I mean, nowadays it's so extremely fancy, but even back then it was pretty fancy. And I was at least able to teach it to remember that as long as this thing that we're calling here, that we're calling on is a nodelist object, that it's okay to remember a lot about what a length is. And that was also a huge improvement on the Dromeo tests, because we could cache most of the metadata about a length lookup on the node list. Anyway, I don't know what I'm trying to say here. I guess I'm just reminiscing about Dromeo optimizations. But it was a good time, and I think, if I recall correctly, it's not like we had some big goal or anything to improve Dromeo. It was just something that we, and me especially, took personally because we just wanted to go faster than Blink after they decided to leave, because it was fun to compete. And of course, we had many other benchmarks too. This was just the one that was really fun to optimize because it did a lot of silly stuff. Like Dromeo does a lot of silly things. I remember there was one subtest of Dromeo that kept annoying me because it had a bug in it that it would leak event listeners, I think. And the faster you would go on the test, the more it would leak. And so if as you improve on this test, it would fuck with you by putting more garbage or more leaks on your heap, basically leaked objects, not garbage, because it couldn't be collected. So that was an annoying one, because there was like this I don't even know how to describe the performance result pattern of that test. It wasn't doing what I was expecting it to do. Let's say that. But yeah, so that was like, we went on like that for over a year, I think, just feeling like we were in this performance war, even though most of it was in our heads. It was still a cool time, because it was a really fun environment to be in, like this super competitive mindset around you. It would have been fun to know what the other guys were thinking. So, if you ever talk to any one of them, maybe ask them what they were doing with performance after the Blink split. Anyway, I guess that's all I wanted to talk about today, so thanks for hanging out with me, and I'll see you next time.